Welcome again. We're going to work on productivity example number 4, and this one is posted in the Brightspace as well. And this example says Enos Industries is compiling the monthly productivity report for its body of directors. From the following data, calculate labor productivity, machine productivity, and multi-factor productivity of dollars spent on labor, machine, materials, and energy. The average labor rate is $15 an hour, and the average machine usage rate is $10 an hour. And we are given this kind of information in a table, which includes the units produced, labor hours, machine hours, cost of materials, and cost of energy. So we are going to create the model and put all this information in our model so that we will be able to we'll be able to find productivity as required, the way we did for the other examples like the first, second, and the third. So all we're going to do here is just to create our model. And the first thing we're going to do is to look at the formula. Or I'll say the formulas. So the first formula we're going to look here is labor productivity. And in this case, labor productivity will be the output per labor. But in this case, you can see that we are given labor hours. And so we can actually find productivity by looking at output per labor hours. But we can also find productivity by using the cost of labor, and I will explain that later. So here can be labor hours, and at the same time, I'm going to copy this. We can actually have a productivity in terms of cost of labor. So that two approaches can be used. And then we have machines. And so we are asked to find the productivity of machine. And we can copy the formulas. And so here we can have machine productivity. And so in this case, we can look at the machine hours, meaning that we will take output divided by the machine hours. But also we can find the cost of machine. We can use the cost of machine because that information is given. So you can say machine. So we can, as I said, we can look at the machine productivity by taking the output divided by machine hours. And also we can look at the machine productivity by looking at output per cost of machine. But still we have one more productivity, which is multi-factor productivity. And in this case, we will look at output per, now we look at all the inputs which we have. And remember, we have labor, but also we have machine. And then we have materials. And finally, we have energy. We can see it here. We have labor, machine, materials, and energy. So you can see that we are given labor hours, machine hours, and then cost of materials and cost of energy. So in this case, we are not able to write here like labor hours, and then let's say machine hours, and at the same time we look at the cost of materials and then cost of energy. We cannot do so because we need unit of measurement, which is the same for all the inputs. In this case, we cannot add labor hours, machine hours, and then cost of materials and cost of energy. We cannot add that. If we had only labor hours and machine hours, then we can see that that will be same unit of measurement, which is hours, and so we can add both. But we cannot include hours and cost and something else. We need to bring them into one. We need to bring them into one scale or one unit of measurement. So in this case, we'll need to find the cost of machine, and for labor as well, we need cost of labor. So in this way, we have same unit of measurement, which is time. Which is cost. And we will consider this as we are going to build our model. So now in this case, we're going to consider the output. We're going to identify what is the output. And if we go back to the question, you can see that we have output in terms of units. So we have units produced. We have 100,000 units produced. So in this case, we're going to write 100,000, and we can say units produced. And then that's all with units. We don't have price of units, and therefore we cannot consider revenue in this case. So we will look at output in terms of units only. So now let's go to the inputs. In this case, we have labor, we have machine, and then we have materials, and then finally we have energy. Those are the inputs that we have. And but before we add all this, let me remove them. So we have first labor, and we have labor hours. So in this case, we have, let's see how many hours of labor do we have. We have 10,000 labor hours. And so I'm going to write here 10,000 labor hours. And then we're given another information, which is $15 an hour for labor. So here we have $15 cost per labor. So we can find labor cost by taking, we put equal sign, and so we'll look at the costs per labor times hours that we're going to spend, which is at 10,000. So we can say cost per labor hour. And so in this case, we're looking at the labor cost for all the hours spent. And so we have this much. Now we can go for the machines. And so we're going to do exactly the same. For the machine, we are also given machine hours, which is 5,000. So I'm going to write here 5,000 machine hours. And for each machine hours, it will cost about $10. So that's yes, it will cost $10. This one was 15, and this one will cost $10. So that's the cost per machine hours. And in this case, we can find machine or the cost of machine, the cost of machine, which will be you put equal sign, and so we'll take $10 times the machine hours, and so in this case we get the cost of machine. Let me highlight this and the other one here. And so in this case, let's see what other information we have. So we have the cost of materials and cost of energy, 35 and 15, 35,000, 15,000. So we have materials, which is 35,000, and energy, which is 15,000. So in this case, we can actually find, we can find the overall cost of input. Let me highlight this as well. So we can find the total input cost. This will be the sum of all these costs of input. So let me put equal sign here, and then click on the cost of labor plus the cost of machine plus the cost of energy plus the cost of materials and the cost of energy. So you can see that we have added all of it, and in this case then we can see that the total input cost will be $250,000. So now we have the total output, which is the number of units produced, and also we have the total input cost, which is $250,000. But at the same time, we have the cost of machine and the cost of labor, cost of energy, and cost of materials. So I'm going to highlight this into a different color. I just wanted to do so. You don't have to, but this is how it can remind me what to do. Okay, so we are going to look for the productivity, and I'm going to put productivity here. So we are looking for productivity of labor. And at the same time, I'm going to look at the machine productivity. And finally, I'm going to look at multi-factor productivity. So for the productivity of labor productivity, all we're going to do is we will put equal sign and take output divided by the labor hours. So let's go back to the formula we have here, output per labor hours. And so all we're going to do is take the output, divide by the labor hours, this one here, and we will get 10. So we can say units per hour spent on labor, or the hour that labor was spent in the production. But also we can consider the cost of labor. So I'm going to write or, and in this case I'm going to use the second formula for labor productivity, which is output per cost of labor. And in this case we have the cost of labor, so I will take output divided by the cost of labor, and that's what we can get. So in this case we have units per dollar spent on labor. we have units per dollar spent on labor. So let's go to the machine productivity. And in this case, we are going to do exactly the same as we did for labor. And we'll put the equal sign to create the function. And all we're going to do is to take the units produced, divide by the machine the machine hours. And so in this case, we have 5,000. And if you enter, we have units per hour. That the machine, if we spend an hour of machine, we're going to produce 10 units. And also, we could use the cost of machine as well. And in this case, we're going to put equal sign. We take 100,000 divided by the cost of machine, which is $50,000. And so in this case, we know that we have units produced per dollar spent on machine. And finally, we are supposed to calculate multi-factor productivity, and therefore we can, in this case, remember we have the total input cost and the output, the total output. And so we will put equal sign, and then we'll take the total units produced divided by the overall cost of input when we add all of them. And so that's what we have as our multi-factor productivity. And in this case, we know that we have units produced in terms of dollars spent on inputs. Dollars spent on inputs. So that's how we could find labor productivity, machine productivity, and multi-factor productivity once we have created our model. Thank you.